Hi class, this is lesson 4.6, perform operations with complex numbers. So complex numbers, this is a new thing for us. So definitely a new thing for you. So some vocab, an imaginary unit is what we call I. Okay, so I is obviously a letter you've used for years. It's going to have a new meaning now. So the imaginary unit I is this. What it represents is the square root of -1. If you put the square root of -1 in your calculator, it's going to give you an error message. Calculators will not do the square root of a negative number because the square root of a negative number isn't really a real number that we can work with. So we, in math, have made up imaginary numbers, not me personally, but many years ago, and that's what I represents. I represents the square root of -1. So I squared, if you did square root of -1 times square root of -1, that's just -1. So the imaginary unit I can be used to find the square root of any negative number. So now we're going to start using square roots of negative numbers. A complex number is the next thing. Complex numbers are written like this: A plus BI. So a number plus another times an imaginary, times I, the square root of -1. Where A and B are real numbers, and I is the imaginary unit. So I is the imaginary unit. In standard form of A plus BI, A is the real part, so it's a real number, and BI is the imaginary part. So I'm going to try and write this as neat as I can. So number 3 here, imaginary numbers. So if B is not equal to 0, then A plus BI is an imaginary number because it has I. If B was 0, there'd be no imaginary part to it. If A equals 0 and B is not equal to 0, then BI is called a pure imaginary number, because it doesn't have any real part. So the square root of a negative number. If R is a negative real number, then the square root of the square root of R equals I times the square root of R. So notice we just put the I there and got rid of the negative sign. So for example here, the square root of -5, we're going to put an I on the outside to represent that negative, and then times the square root of 5. Also, if you have I times the square root of R squared, the quantity squared, that just equals -R. And the reason why is the square root of R squared would be R. I squared is -1, so -1 times R would be -R. So that makes sense. So let's do some solving quadratic equations here. So the last lesson, last one or the one before that, I think it was just the last one, we talked about undoing squares. So this x squared is all alone, so to undo it, I'm going to just take the square root of both sides. So I have x over here equals, now to get rid of that negative from the radical, we're going to do I. Now I'm taking the square root, so I got to have a plus or minus sign here as well. And then I have the square root of 12. Well, we got to think about, is square root of 12 simplified? Are there any perfect squares that go into it? Yeah, 4 does. So we have x equals plus or minus I times the square root of 4 times the square root of 3, because 4 times 3 is 12. So x equals plus or minus. Now the square root of 4 is 2, so we write it in this way. We would write 2I times the square root of 3. So that represents positive 2I times the square root of 3 and negative 2I times the square root of 3. Looking at number 2 here, remember from the last lesson that the squared has to be alone in order to take the square root of both sides. So we've got to move 15 first. So I'll subtract 15 from both sides. So I have 2x squared equals -35 minus 15 is -50. X squared still isn't alone, so we're going to divide both sides by 2. X squared equals -25. And now that x squared is alone, I can take the square root of both sides. So x equals, to get rid of that I, or that negative sign, we're going to take an I. So we're going to say plus or minus I. And then the square root of 25 is 5. But this isn't in the right order. We wouldn't say I5. We would say x equals positive or negative 5i. We always put the number first and then the I. Let me move my notes up here. So now we're going to do some operations with complex numbers. A couple of the operations are addition. So if we're adding a plus bi plus the quantity c plus di, we add our real parts, then we add our imaginary parts, and then put the I like that. If we're subtracting, we're going to subtract our real parts, and then subtract our imaginary parts, and then put the I on the end. So let's write these as a complex number in standard form. So this one is adding, so I'm going to add my real parts, add my imaginary parts, and use that to simplify. So my real parts would be 12 plus negative 8, plus my imaginary parts, I've got a negative 11 plus 3, and those both have the I, so I'll put the I behind that. 12 plus negative 8 is 4. Plus negative 11 plus 3 is negative 8, and I've still got the I, so this is really 4 minus 8i. And that would be my simplified form, 4 minus 8i. This next one is subtracting, so I'm going to subtract my real parts first, 15 minus 24. And then I'm going to add to that, and I'm going to subtract my imaginary parts, negative 9i minus negative 9i. Now I should have taken those i's and put it on the outside, like that. So 15 minus 24 is negative 9, plus negative 9 minus a negative 9. That becomes plus 9, which is really just 0, and I still have I. Well, 0 times anything is 0. It goes away. So my simplified form is just negative 9. The next one here, I've got 35 minus the quantity, 13 plus 4i. Well, one thing that you could think of is my real part in this first one is 35. And I have to minus my real part in the second, which is 13. And I'm going to add to that. Now this one, I don't have an imaginary part. Oops, I meant to point. This one, I don't have an imaginary part. So really, it's just 0 minus 4i. So plus 0 minus 4, I have my I there. Because I don't have an imaginary part in the first one, so I can do it this way. 35 minus 13 is 22, plus 0 minus 4 is negative 4, and then I've got my I right there. So it's 22 minus 4i. And there is my simplified form. Down here at the bottom, notice that 5i is on the outside. So we need to distribute it to everything on the inside. I'm going to change my color here real quick. So negative 5i times 8. So we do negative 5 times 8 and then keep the I there. And then negative 5i times negative 9i. So plus negative 5i times negative 9i. So negative 5 times 8 is negative 40. And I've still got my I there, plus negative 5 times negative 9 is positive 45. I times I, though, we set up above, that's I squared, and so that's just really times negative 1. So it's negative 40I. 45 times negative 1 is minus 45, so minus 45. And then if I put this in standard form, it would be negative 45 minus 40i. And there's my simplified form. Number 5 here, I have two binomials being multiplied, so I know I need to use FOIL. Negative 8 times 4 first, plus negative 8 times negative 7i. Trying to write as neat as I possibly can. Plus, distribute this last one, 4 times 2i, plus, distribute this last one here, 2i times negative 7i. Okay, a lot of simplifying. Negative 8 times 4, that's negative 32. Plus, negative 8 times negative 7 is positive 56i, plus 4 times 2i is 8i, plus 2 times 7, well, that's negative 14. I times I is negative 1. So negative 14 times negative 1 is positive 14. So now let's combine our like terms. Negative 32 and positive 14 is negative 18. Plus 56 and plus 8i is 64i. So this is my simplified form. Let's turn the page and look at the back. Okay, so we are now going to do some graphing on our complex plane. So it says a coordinate plane in which each point AB represents a complex number A plus BI. So here my A is first, my real part goes first. And that's in the X spot, so my real part's going to go right here. My B is my imaginary part, that's second, that's in the Y spot, so my imaginary part's going to go right here. So that's what this says. The horizontal axis is the real axis, and the vertical axis is the imaginary axis. So let's label that just so that we remember this. The Y is the imaginary, and the X is the real. So really, this is just I, this is 2I, this is 3I, and 4I, and down here would be negative 1I, negative 2I, negative 3I, and so forth. And then on the X coordinates, just 1, 2, 3, negative 1, negative 2, negative 3, just like before. So let's plot these points. Okay, my real part is 4, so I'm going to go over 4, and then I'm going to go up to 2I. So over 4, up to 2I would give me right here. So that's A, 4 plus 2I. B, negative 1 plus 3I. So on my x-axis, I'm going to go to negative 1, and then I'm going to go to positive 3I, which would be right there. So B is right here. C is just 3, and so really I could think of that as plus 0I. So if I go over 3 and then go up 0, it'd be right there. So 3 really plus 0I would be right here. So there's C. D is negative 4I, so really I could think of that as 0 minus 4I. So my real part is 0, I'm going to go over 0. Here's my A, and then here's my B, down to 4I. So I'm going to go over 0 and down to 4I, which would be right here. There's my D. And then E, negative 2I, or negative 2 minus 2I. So I'm going to go to negative 2, then I'm going to go down to minus 2I, so it'd be right here. So negative 2 minus 2I is right here, and there is E. And the last part we are going to skip. You do not need to do that. So please make sure if you had any questions, you starred them so we can talk about them in class tomorrow, and have a wonderful day.